So to finish the problems from section 3.5 and 3.6, so let's take a look at practice number 3 from section 3.5. The question is asking us which of the following could be used to find the slope of the tangent line. Again, remember, anytime you see this slope of the tangent line, you need to be thinking finding your derivative. To the curve inverse tangent of x minus 2y plus 2 equals x squared minus 3y plus inverse tangent of 2 minus 1. So really what this question is asking us is to find our dy dx. So I need to find the derivative. I am going to have to apply my chain rule when I take the derivative of this inverse tangent. Again, I know when I take the derivative of inverse tangent, it's going to be 1 over this 1 plus x minus 2y plus 2 to the second power, because remember the derivative of inverse tangent is 1 over 1 plus x squared, times. Now I have to take the derivative of what's inside, so that's going to be 1, minus the derivative of 2y is 2, times dy dx, and the derivative of plus 2 is 0. Equals, again I take the derivative of x squared, which is a 2x, the derivative of minus 3y is minus 3 dy dx. Now inverse tangent of 2, there's no variable inside of this, so that is just a constant. So that would go to 0, the derivative of minus 1 is 0. So again, if you take a look at your answer choices, your answer choice has to be choice C. So the answer choice for practice 3 would be C. Okay, so now let's take a look at example number 4 on page 2. So here they're giving you s of t, and notice they want me to find the second derivative. So remember, I can't find the second derivative unless I find the first derivative first. So for example 4, to find the second derivative, I first have to find the first derivative. So my first derivative, s prime of t, again 3t to the e. Now remember, e is a constant and that is in the exponent. So I am going to have to use my power rule. So I'll have to leave this in terms of e when I take this derivative. So for example, when I take the derivative of 3t to the e using my power rule, it's going to be 3e to the 3e times t to the e minus 1. Remember, all of that 3e is a constant. Plus, and again I have to subtract 1 from the exponent, that's a constant. When you take the derivative of a log function other than a base of e, it's going to be that 3 to the t times the natural log of the base, which is 3. Minus, I am going to have to take the derivative of negative 4e to the 5t, and I am going to have to apply my chain rule. The derivative of 5t is a 5, so I'm going to multiply negative 4 times 5, which is a negative 20, e to the 5t. I am going to have to apply my chain rule when I take the derivative of sine of negative 2t. Again, the derivative of sine is a cosine, and then the derivative of the inner function is a negative 2. So when I clean up this first derivative, that's going to give me 3e times t to the e minus 1 plus 3t to the natural log of 3 minus 20e to the 5t minus 2 times the cosine of negative 2t. So there's my first derivative. Let me just make sure I did that right. Yes. Yeah, okay. So now when I go ahead and I want to take the second derivative, again, this 3e is a constant, so I'm going to, again, just use my power rule. I'm going to take the derivative of te to the negative first, so that's going to give me 3e times this exponent of e minus 1 times t raised to the e minus 1, which is a minus 2. So again, all I did was use my power rule when I took the derivative of t raised to the e minus 1. Again, pull down that e minus 1 and subtract 1 from that exponent. And then that 3e, again, I just using that constant multiple rule of derivatives, I just pulled that out. Now remember, this is not going to be a product rule. Natural log of 3 is just a constant. So when I take the derivative, I'm just going to pull my constant of natural log of 3 out, and take the derivative of 3 to the t. So again, the derivative of 3 to the t is 3 to the t times natural log of 3. Minus, when I take the derivative of 20e to the 5t, again, I'm going to have to apply my chain rule. Again, the derivative of 5t is a 5, so negative 20 times 5 is negative 100. And then finally, I'm going to have to apply my chain rule again to negative 2 cosine of negative 2t. Again, I know the derivative of cosine is a negative sign, and a negative times a negative is a positive. So that's going to give me a positive 2 sine of negative 2t, but then I need to take the derivative of the inner function, which is a negative 2. So when I clean up the second derivative, I have 3e times e minus 1 times t raised to the e minus 2 plus natural log of 3 times natural log of 3 could give me natural log of 3 squared times 3 to the t minus 100 e to the 5t, and then this is going to become a minus 4 sine of negative 2t when I clean up that second derivative. So just be careful you recognize what are constants and what are not, so you avoid using that product rule. So any questions on, well, you can't ask any questions because it's a video, but anyway, if you have any questions, you can come in during advisory or for some extra help. All right, let's take a look at B. Now this is asking you to find the third derivative of cosine of negative x, and we're going to evaluate this at pi over 3. Well, like I said, you can't get to the third derivative without first getting to the first and second derivative. So to find my first derivative, I am going to have to apply my chain rule. I know derivative of cosine is a negative sign. Times, again, I have to take the derivative of the inner function, which is a negative 1. So that's going to give me sine of negative x. So there's my first derivative. So then I'm going to find my second derivative. And my second derivative is going to be taking the derivative of my first derivative. Again, I'm going to have to apply my chain rule again. The outer function is sine, so the derivative of sine is a cosine. So cosine of negative x times the derivative of my inner function, and the derivative of negative x is a negative 1. So that's going to be negative cosine of negative x. So there's my second derivative. The third derivative, again, I'm going to apply my chain rule. Well, the derivative of cosine is a negative sign, and a negative negative becomes a positive. But then I have to take the derivative of the inner function, which is a negative 1. So that's going to give me negative sine of negative x. So now I want to find the value of this derivative at pi over 3. So negative sine of negative pi over 3. So negative pi over 3 is down there in quadrant 4. The sine of negative pi over 3 is going to be negative square root 3 over 2, and a negative negative will become a positive. So the answer to this is going to be positive square root 3 over 2. Again, negative pi over 3, remember, is down here in quadrant 4. It's in exactly the same location at 5 pi over 3. So the y-coordinate down here at 5 pi over 3 is negative square root 3 over 2, but then you have to negate it because of the negative sign in the front. So practice 5, we did example 5 in class. Let's take a look at practice 5. Find the instantaneous rate of change of f prime. So now remember, this is another way of them asking you. You're taking the derivative of the first derivative. So the instantaneous rate of change of f prime, I need to take the derivative of the derivative. So f of x is cosine of 2x. So to find f prime of x, again, I'm going to have to apply my chain rule. The derivative of cosine is a negative sign. And then I have to multiply by my inner function, which is a 2. So this is going to give me negative 2 sine of 2x. So now I'm going to have to take my second derivative. So again, I have to use my chain rule again. The derivative of sine is going to be a cosine, so this is going to be a negative 2 cosine of 2x times the derivative of the inner function, which is a 2. So the second derivative is negative 4 cosine of 2x when I multiply 2 times negative 2. So now I want to find the instantaneous rate of change at pi over 3. So I'm going to plug pi over 3 into my second derivative. Again, so 2 times pi over 3 gives me 2 pi over 3. And from the unit circle, I know that the 2 pi over 3 is in quadrant 2. Cosine is negative in quadrant 2. And the x-coordinate at 2 pi over 3 is going to be negative 1/2. So the instantaneous rate of change at x equals pi over 3 is going to be 2. Okay. We did the first two parts of the FRQ in class together. So now let's take a look at part C. They want me to write the equation for a line tangent to the graph, g, which is your inverse function, at x equals negative 2. So again, when we take a look at this particular problem here, they want us to write the equation for the inverse function of g at x equals negative 2. So I always go back to my chart. Remember, anytime you're writing an equation of a line, you have to know the point, you have to know the slope. Because remember, you're always trying to put it in the form of y minus y sub 1 equals m times x minus x sub 1. So now, on the inverse, we want to write the equation of the tangent line at x equals negative 2. So that means the point on my inverse function of g has to have an x-coordinate of negative 2. That means when I take the, looking at the point on g, so g of something has to have a y value of negative 2, because remember, you switch the x's and the y values. So now when I look at my table, what x-coordinate has a y value of negative 2? So when you look at your table, the y-coordinate for g of x that's equal to negative 2 is occurring at 3. So what I know then is that g of 3 has to be equal to negative 2. So then on my inverse for function g, the point's going to have to be negative 2, 3. So this is the point I'm going to use when I go to write the equation of my tangent line. So this is my point. Now I have to worry about the slope, which I know comes from the derivative. So what I need to then do is find g prime of 3. So from my table, g prime of 3 is equal to negative 4. So then by my relationship of a function and its inverse and the derivative, I know the value of the derivative for the inverse of g is going to have to be the reciprocal, which is negative 1/4. So there's my slope. So now I know my point, now I know my slope, I can write the equation of my tangent line. So again, y minus 3 is equal to negative 1/4 times x plus 2. So this chart just really helps me filling it in. When I just remember, every time they write you write the equation of a tangent line, you always have to know the point and you have to know the slope. Then finally, for the last part, D. They're telling you have a point that lies on the curve in the xy plane given by this particular equation. They want me to find the value of dy dx at the point 3, 1. So I know that I'm going to have to take the derivative, and then I'm going to evaluate it at the point 3, 1. So first of all, when I take the derivative of the quantity f of x squared, I'm going to have to apply my chain rule. So this is going to be 2 times f of x. So that's the derivative of the f of x quantity squared, plus g of x. So that's just going to be plus my g prime of x. That's going to be equal to, when I take the derivative of xy, I am going to have to apply my product rule. So f prime g, so that's going to be 1 times y, which is y, plus f, which is x, times my g prime, which is my dy dx. And then the derivative of minus 1 is equal to 0. Now remember, you don't have to solve for dy dx. we want to evaluate it at the point 3, 1. So you can plug in the values and then solve for dy dx in the end. So anywhere I see an x, I'm going to plug in a 3. Anywhere I see a 1, I'm going to plug in a y. So I have 2 times f of 3 plus g prime of 3 equals the y value is 1 plus the x value is 3 times dy dx. Now remember, in the very beginning, I highlighted an initial condition. The very beginning, they told you that f of 3 was equal to 2. So I know that f of 3 is 2. So 2 times 2. Plus, g is represented by the table. So g prime of 3 is going to be negative 4. Equals 1 plus 3 dy dx. Now that I've plugged in my constants, I can solve for dy dx. And I realized something back when I did my derivative up here. I forgot to actually multiply by the derivative of the inner function, which should be an f prime of x. Because remember, when I do the derivative of f of x squared, the derivative, again, I have to do the derivative of the outer function times the derivative of the inner function, which is my f prime of x. So I should have an f prime of x written right after this. So that should be multiplied by f prime of 3. So that I have the 2 times 2. Now the f prime of 3, remember, f prime of 3, I actually found, save yourself from work, I actually found f prime of 3 back here in part B. Or, like I said, if you did not recognize that, you'd have to plug 3 back into the derivative that they actually gave you. But in part B, we found that f prime of 3 was that 0.986. So we should have 2 times 0.986. And again, that's going to be my minus 4 equals 1 plus 3 dy dx. Sorry that I left off that f prime there. So then when I multiply, again, because remember this is a calculator question, so I'm going to have 2 times 2, which is 4, times that 0.986. And then I'm going to subtract 4. And then to finish solving for dy dx, I'm going to subtract 1. And then I'm going to divide by 3. So I end up with negative 0.352. So dy dx at the point 3, 1 is equal to negative 0.352. Again, just remember up here, I apologize about that, I didn't catch that earlier. The derivative of the inner function is going to be that f prime of x. So then I have to multiply 2 times f of 3 times f prime of 3. And again, f prime of 3, remember, was found up here in part B, or you can just simply plug 3 back into the derivative that was given.